Alright, let's go. We are now under index equation reducible to quadratic equation. We just finished solving index equation. Now let's move ahead. Now index equation that is reducible to quadratic equation. That is what we are taking now. I know I decide to call it meat because it's somehow hard and at the same time very, very interesting. I'm telling you, it's very, very interesting. Please pay attention. Let's do it together. Okay, now let's see this number one question. It says solve the index equation 2, you open bracket, 2 raised to power 2x, you close the bracket, minus 5, open bracket again, 2 raised to power x, close the bracket, plus 2 is equal to 0. Okay, you see this? What I'm going to do is say 2 open bracket, 2 raised to power 2x, you close it, minus 5, close open bracket, 2 raised to power x, close it, plus 2 is equal to 0. Now pay attention and see what we're going to do. Okay, now let's go. We have 2 open bracket 2 raised to power 2x. This 2 raised to power 2x can be splitted into 2. Okay, so if you split them, you will have, okay, look at what I wanted to do. Okay, so we're going to put one of those terms, we have 2x, 2 terms there. Okay, so I'm going to put 1 inside the bracket and 1 outside. Okay, so what I'm going to send outside, we're going to send 2 outside, so that when you open this bracket now, it will still remain the same. Okay, we talked about this in one of our laws. Okay, now look at what I wanted to do. We have 2, you open bracket, 2 raised to power x, close the bracket, raised to power 2 now. Do you see it? Okay, then minus 5, open bracket, 2 raised to power x, close it, plus 2 is equal to 0. Okay, now pay attention here. We want to solve this, and what we want to do is, since we have 2 raised to power x in common here, let's just decide to call it a name. Okay, let's decide to call it maybe a letter. Okay, let's use p. Okay, we'll say let 2 raised to power x equal to p. So in the above expression, anywhere we see 2 raised to power x, we're going to replace it with what? P. Okay, so now let's see how it will look like. We'll have 2p. You discover that this is having square, right? It will now give you 2p squared minus 5p plus 2 equal to 0. Yes, you just discovered that this is exactly a quadratic equation. Alright, now let's go and solve this. Okay, in solving this, let's just use factorization method. In factorization, we'll ask yourself, okay, you first of all multiply the coefficient of p squared by c. So it will give you 2 times 2, it will give you 4, right? Now you ask yourself a question, the two numbers that when you add them together, it will give you minus 5. Then when you multiply them, it will give you 4. Okay, so the two numbers are minus 4 and minus 1. So minus 4 minus 1 will give you minus 5. And then minus 4 times minus 1, it will give you 4. Okay, now let's go. Let's fix it in place of 5p. Okay, now we will have 2p squared minus 4p minus p plus 2 is equal to 0. All right, good. Let's go. From here, let's group them 2 by 2. So we're going to have 2p squared minus 4p in bracket minus p plus 2 in bracket equal to 0. Okay, now let's factor out. In 2p squared minus 4p, what do they have in common? As we can see, 2p is common between them. So let's factor out 2p. So when you factor out 2p in 2p squared, what will be remaining there will be what? P. then when you factor out 2p in 4p, what will be remaining is 2. So that when you say 2p multiplied by p, it will give you 2p squared. Then when you say 2p multiplied by 2, it will give you 4p. Okay? Now, minus, what do they have in common? They have 1 in common. Okay? So say minus 1. So open bracket, whatsoever that is in the first bracket, let's put it here. Okay? So we'll have p minus 1. And then let's check if it is correct. When we say minus 1 times p, it will give you minus p. The minus 1 times minus 2, it will give you positive 2. Yes, that means we are correct. Now let's go. We have 2p minus 1. And then p minus 2 is equal to 0. From here, we picked the two values outside the bracket and then one of the brackets. Okay, now let's go. We're going to have 2p minus 1 is equal to 0, or p minus 2 is equal to 0. Okay, now we are looking for p in this 2p minus 1. Okay, let's say I'm going to be, we're going to have 2p, we send 1 minus 1 to the other side to give you 2p is equal to 1. Okay, then we say or p is equal to 2. That is, you say minus 2 to the other side. Okay, we send it to the other side. Right, now let's go. We are looking for p. That means we divide both sides by 2. Okay, that is having 2p. Now we have 2p divided by 2 is equal to 1 divided by 2. Okay, now we have p is equal to 1 all over 2, which is half, or p is equal to 2. Now, but you remember that we say that our p is 2 raised to power x. Okay, that means the values that we just gotten now is for 2 raised to power x. Okay, now that means you're going to say 2 raised to power x is equal to 1 all over 2, or 2 raised to power x is equal to 2. Okay, now let's go. We say 2 raised to power x is equal to this 1 all over 2 can be written as 2 raised to power minus 1. Is that true? Yes. Now let's write it this way. Now we say or 2 raised to power x is equal to 2 raised to power 1. When you say 2 raised to power 1, is it not the same as 2? It's the same. Now let's go. Since they are all having the same base, we can do away with the base and then go ahead with the exponent. So when we do away with the base, in the first one we have x is equal to minus 1, or x is equal to 1. Yes, we have just finally solved this. Okay, now for you to check whether what we solved is correct, substitute for minus 1 and then for 1 in the above index equation. You discover that it satisfies the condition there. Okay, it is correct, it is satisfied. All right, thank you very much. Please keep practicing, keep watching. Let's do it all together. All right, thank you very much. See you next time. Let's see number 2.